Bohr's theory of hydrogen atom. Let us assume that a hydrogen atom. So the hydrogen atom has only one proton. So we take it as a atomic number of the hydrogen atom as a Z. E, that is a positive charge. Proton is here. The electrons are only one electron is revolving around the nucleus. So the velocity of the electron is V. The mass of the electron is M. So there will be a force of attraction, Coulomb force of attraction between the positive charge and the negative. So F is equal to K Q1 Q2 by R square. Q1 is a nucleus charge ZE and Q2 is a electron charge E by R square. So as per the concept of Rutherford as well as the Bohr's concept, the centripetal motion of the circular motion of the electron revolving around the nucleus is equivalent to the electrostatic force of attraction between these two things. So again I will say that the centripetal force required for their rotation is provided by electrostatic attraction between electron and nucleus. So that centripetal force must be equal to electrostatic force. So Fc is a centripetal force and Fe is a electrostatic. So what is the centripetal force? mv squared by r. Whose centripetal force? Electrons. So there will be a centripetal force on the electron, that is mass of the electron, velocity of the electron by radius of the orbit, which is equal to electric force kz e squared by r squared. Then what is the r? So we have to solve this r and this r get cancelled. You bring this r here and mv squared denominator means kz e squared, kz e squared mv squared. This is the equation number 1. So this is the radius of the orbit we are obtained by using the centripetal force and the electrostatic force. Then according to Bohr's quantization condition, angular momentum of the orbit is equal to mv square. mvr is a centripetal force, that is angular momentum of an orbit is equal to nh by 2 pi. So r is equal to nh by 2 pi. What will happen? This m will come to the denominator, means this one. So this is the Bohr's equation. This also represents the radius of the orbit. This also represents the radius of the orbit. So both the radius are equal, but this is the concept of centripetal force and Coulomb force. This is the concept by using the Bohr's quantization condition. So both are equal. If you equating these two things, kz e squared by mv, nh by 2 pi into mv. So m get cancelled. Then V and V get cancelled. One V is there. You bring this V here and this nh denominator and 2 pi in the numerator. 2 pi kz e squared by n. So this is the velocity of the electron revolving around the nucleus in any orbit. If you put the z is equal to atomic number and n is a number of which orbit it will be revolving. So the atom, for the hydrogen atom we have to substitute z is equal to 1. For hydrogen atom only one electron is there, so there must be n must be 1. First orbit only electron will revolve. So substituting this equation 3 in equation 1, so only we are able to find the real radius of the orbit. So why we can't substitute in this equation, sir? Very simple. The Bohr only clearly explained the stability of the atom, because whenever the electron revolving around the one particular stationary orbit whose angular momentum is L is equal to nh by 2 pi, means then only the electron will not fall into the nucleus whenever the electrons are revolving around the nucleus. So the Rutherford disadvantage, that is a limitation, is overcome and rectified by using the Bohr's postulates. The angular momentum of the electron or the orbit is equal to nh by 2 pi. So only this velocity of the electron is substituted in equation 2. Mostly the students are confused with that. Here also radius are, here also radius are. Why we can? So if you substituted here, we are moving to Rutherford atom model. So now we are going to solve the hydrogen atom problem by using the Bohr's theory. So only we are going to substitute in this equation. So if you substitute what are nh by 2p, mv is there. M is as usual. So m will come, that is here nh by 2 pi mv, nh by 2 pi m. Instead of v only we are going to write this equation. So this is the mass m. So instead of v, 2 pi k z e squared, 2 pi k z e squared, then nh will come to the numerator. So n squared h squared then 2 into 2 4 pi squared m k z e squared. So this is the actual radius of the hydrogen atom. First orbit means we have to substitute n is equal to 1, z is equal to 1 for hydrogen atom. This is a general equation for any atom. For hydrogen atom, z is equal to 1 and n is equal to 1 means approximately we get an equation solution 0.53 Armstrong. So this value is approximately equal to this one. And one more thing, so we should not write like this what I am written in the previous. So this is a correct value. So Bohr radius is 0.53 Armstrong. So by substituting this R0 value and by using this, we can calculate the velocity is equal to 1 by 137 c by n. So the velocity is 137 1 by 137 c by n. So this will explains the fine structure constant. This is a fine structure constant explains clearly. So Bohr atom model clearly explains the spectral series also. Thus the speed of the electron in the innermost orbit is 1 by 37. This is the speed of the electron, 1 by 37 times the speed of the light in vacuum, while the speed in the outermost orbit varies inversely with, what is that, n value. So again I will say that the speed of the electron in innermost orbit is 1 by 137. Innermost orbit means n is equal to 1. So innermost orbit is 1 by 137 times the velocity of light in vacuum. But what is that? While the speed of light in outermost orbit is varies inversely with the n. So dear students, understand the Bohr's theory of hydrogen atom. So this is the Rutherford theory only, we are using that. Then by substituting the Bohr's quantization condition, we are obtaining the radius of the orbit, that is equating the centripetal force and the Coulomb force, equating radius of the orbit with the Bohr's quantization. Finally we get the velocity of the electron revolving around the atom. By using this velocity we can again find the exact value of radius of the hydrogen atom. That is the first orbit radius is 0.53 Armstrong. This is a very important derivation which is frequently asked in board examination. So this is asked in 3 mark question. So understand the concept clearly. So there will be a continuation of this part also, the energy. So now we are going to find the energy of an electron. By determining the energy of the electron in different energy levels, we are going to find that spectral series of the hydrogen spectrum, which is not clearly explained by Rutherford atom model. Now by using the Bohr's theory of atom model, we are able to clearly explain the spectral series of the hydrogen atom.